Hello folks, how's it going? My name is Leo, also known as Knockdeaf, and today I will be teaching you all how to make an incredible hologram shader perfect for your sci-fi game. So this shader has many different features. It has a little bit of a twitch and it uses very few textures. Most of the stuff we're doing here is actually done mathematically. We're using AMPLIFY shader editor and Unity, but as always, if you know your way around shader editors, you can probably follow along no matter whatever visual shader graph you use. This can work on anything. Just the little nodes are going to be named different, but the concepts are there. Once again, this uses very few textures, so it's great also for you to learn a little bit about UV manipulation, a little bit about, some mathematical tricks you can apply to your shader, and it looks really great. So let's jump into the engine. Here we have the final result on Unity. So you can see here the shaders. I have some particle systems that I made just for showcase purposes. So I have a little bit of a better showcase, but the bread and butter is of course the holograms themselves. The accompanying particles are just fluff. But you can see here that this works on 3D models as well as with quads, just like this one. These are two materials using the same shader, but I messed with the settings a little bit so they look a little bit different. And also this one has a very strong vertex distortion so that it shows a little bit better since it is a 3D model and not a plane. Let's begin. We'll be using AMPLIFY shader editor for this. I am on HDRP, but your pipeline, your Unity version doesn't matter. This should work everywhere. So I have a shader here that I made so that we can kickstart things. And you can see here that this is an empty, unlit shader set to be transparent. And all I have, literally all I have, is a texture hooked up to the color, emission, and alpha. That's all I have, just so we have a kickstart point here. I have a material that has this texture, so just so that we can see what we're doing here, this is going to be our shader, and we're going to control it over time through here. So let's begin. So the first step that we're going to do here is that we're going to add a UV distortion glitch type of thing to the Piloto Studio texture. Of course, this texture can be anything you want, but I think that is a very good first step. We're going to be using the AMPLIFY named variables so that we can create blocks of logic. So the first block of logic we're going to create is about this UV distortion. So let's go here and allow me to introduce you to the principles here. A lot of the things we're going to use in this tutorial is from this node right here, the noise generator. This is available also on the Unity default shader graph. It's a little bit different, but you can get pretty much the same result. And we're going to be using this guy to seed a lot of the randomness and a lot of the actual visual inputs that we're going to see today. So let's go through it. The first thing we are going to do here is that we're going to make a new vector 2, right? So you can just create a new vector 2 here. And this is going to be our glitch tiling control. And by default, we can set this to be something like 8.8, something like that. What we're going to do is that we're going to manipulate the UV and the scale of this noise here. So if I take my UV node and I hook it up here, and I take my scale and I just raise it up a little bit, you can see what this node does. It generates this noise, just blacks and whites, based on the actual input from the UV and the scale. What I want to achieve is that I want to manipulate my UV coordinates and the scaling of this so that it almost looks like a bunch of blocks going in and out. The scale is actually the easiest one because if we wanted to do things over time, well, we need a time node. And interestingly, the time node, it's a float that just goes up and up and up and up. But for our glitch, we want things to be erratic and kind of flashing in and out and just repeat themselves erratically. And a good way of achieving this is by using a fraction. And essentially, this node kind of repeats the numbers. It's easier to see if you plot on a Cartesian plane, but essentially, it just repeats the functions based on a given time frame, right? If I just put this here into the scale, you're going to see what's going on, right? You can tell that the noise is doing a motion and then repeating that motion over and over and over again, right? It is contracting, expanding, contracting, expanding, contracting, expanding. So what we want to do here is that we actually want the scale to be bigger. So to do this, we can add, and here we're going to add a really high number. So let's use 50, for example. scale. And if I put this into the scale, you can see what's going on. You can see that our noise is kind of expanding, contracting repeatedly, but it's very abrupt, right? Let's make this bigger. Let's make this 70, so even more concentrated. But this is not enough though, because we also want to manipulate our UV coordinates, so they're very erratic as well. So what we're going to do here is that we're going to make different operations on the X and on the Y. So we're going to drag out this X here, and we're going to multiply it, and we're going to multiply it by the fracted noise that we have. We need to also use the Y, so what we're going to do is that we're going to append a vector 2 here, put this on the X, and the Y on the Y. Great. So now, if we slap this into the tiling, you can kind of see the type of effect that we are getting. We are just getting this very frantic, noisy movement, but here's a little trick. I actually don't want this UV, because if you look at the UV here, the way it goes, that the UV is a gradient. But glitches, they're very either on and off, they're very binary, right? So what I can do, wouldn't it be nice if I just said, all right, let's take this gradient on the UV, but I want to keep only the highest numbers of these gradients, only the extremes, so that it's very binary. Well, guess what? That's what flooring is on mathematics. So if we can do here a floor, then when I hook this up, instead of having a very nice and granular UV, we're going to have very binary ons and offs. And you can see here what that looks like. So finally, to tie things off, in the future, it's going to be interesting for us to control the speed of everything that's going on here. So let's create a new float. Let's make it a property, and let's call it glitch time scale. The default value is going to be 1. Let's just plug it in. So later on, we can control the speed at which all of this happens. So let's turn this into a block of logic, if you will. So this is going to be our glitch UVs. Well, I guess this is fair to say that this is going to be our glitch blocky noise. And we're going to save this for later, because something else that we want to do is that we want to have major override control on the glitch. And actually, what I think we're going to be doing here is that we're going to be using a noise and sampling that noise to add glitchy variation not only to the texture, but also to operations like these that we're going to do in the future. So let's create a new texture. Let's call it glitch noise. All right, perfect. Let me select here just a random noise here. This one. It's just a noise that we have from Piloto Studio. So now what we're going to do is that first things first, we're going to mess a little bit with the UV here. So here's a trick. You see this glitch timescale thing? This glitch timescale, it is set to be a property. What if I want to use this logic here again? Well, what I can do, I could promote this into a variable, but something else that I can do is that I can select this particle here, this property, and instead of it being a property here, I can, instead of create, I can set it to fetch. So it is actually going to get the value from this one. Well, hold on, I just gotta change here if you duplicate it, it adds on 1 there. So we don't want to have the 1 there. If it's a fetch, it can have the same property name as this one that is set to create. So whatever this value is, we're gonna use it over here. Great. So now we have, once again, the repeating time trick. And what I think we want to do here is that we want to kind of change, we want to pan through this glitch noise at a given speed. So what we're gonna do here is that we're gonna do a type of faux flipbook. And for that, we're going to divide, and we need to control, if you will, the frequency of this glitch panning. Let's call this glitch frame rate. Let's wait. All right, so now that we have our frame rate here, what we're going to do is that let's put it at a max of 30. Let's put it at a minimum of like 1. Let's put a minimum of 0.5 so that you can have really stuttering values. And what we're going to do here is that we're going to divide this by 1. So we're actually going to do 1 divided by whatever our glitch frame rate is, and we're going to plug this into our later division. We're also going to copy over this divide, and we're going to do this operation once again. So here we have it, this very granular number, because since we are dividing it by 1, we're essentially going to be turning this into like 0 point whatever, like a really low number. Now on here, we're going to floor once again, and we're going to multiply both of these values together. Now, if I plug this into the UV, you're going to realize that we have essentially a gray blob, and this gray blob is going to be cycling through everything there. So we can maybe even increase a little bit of this glitch frame rate so that we can see a little bit better of what's happening. So let's put this at 8, for example. So you can see now that this is just an amalgamation of either blacks and whites kind of flashing in and out. So what we're going to do here is that we are going to take one of these. We can take the green one since it has an extra bit, and let's multiply it by a really high value. We used 70 before, so let's use 70 on this one as well. And this is gonna, of course, increase the intensity a lot. You can't really tell that it's flashing, but it is, because essentially, you know, you can't tell that it's flashing because it's too bright of a value. So, you know, it max out at 1, and we're going to fraction it once again. And this value, now that we have a more binary on and off type of thing, we're going to save it on a local variable. So for that, you're going to register local var. We can call this glitch seed, perhaps. And now we can just save this as glitch noise. Well, actually, we can call this glitch noise so that we don't get confused later down the line. All right, great. So now that we have this glitch noise, we can blend those two elements together to get the blocky UV distortion that we're going to apply to our texture. Let's do it. All right, so the first thing we're going to do here is that we're going to take our current noise that we have and we're going to step it. Now, the way that step works is that it essentially has an input on the B, and this input, as I raise it, you can see that the more I raise, the more we can see of the little squares, and the more I decrease of this value, the less we can see. So this is essentially culling out values that are above or below 0.31 in this case, right? Since I set it to 0.31 there. So what we can do to this is that essentially we can create variations of the same noise if we use different values. So these are going to be exactly the same because they're both using 0.31. But if I change this to be 0.1, you can see that now both steps are different. So this means we can add a lot of variation and randomness by using 2 steps. So what we're going to do here on the first step is that we are going to create a new variable. This is going to be a property, and we're going to call this glitch block size. Let's call it like that. And let's make this property. And here on the default values, let's put it from 0.1 to 1. Whoops, 0.1 to 1. Okay, great. So now it's a slider. And what we can do here is that we can actually multiply this value by our glitchy noise. So we can take here, G is the shortcut for you to get a local variable. We can get the glitch noise and put it as input on the B. And now you can see here that this value is going to have a little bit of randomness also seeded into it. And we're going to put this little fella. We can actually add this value as well to get further randomness. So we can do one where we add, one where we don't, for example. And now we can put here on the step. You can see here the kind of crazy thing that is going on there. We can actually increase this value further here on the add, because I'm not getting the amount of lines that I wish I was getting. Yeah, we can maybe increase the tiling here as well. Yeah, I think this is looking better for my taste. So once again, this is a matter of taste, right? I personally like the smaller blocks, personally. So what we're going to do here on our another step is that we can just put the glitch noise raw. They are looking quite alike, I must say. But what we're going to do now is that we're going to subtract one by the other, which is once again going to generate even more randomness, because now we have 2 completely random things being subtracted by each other. And you can see here that this is an incredibly glitchy value that is almost impossible to distinguish what's going on. Something else is that we're going to saturate. So saturate is the same as clamping the values from 0 to 1, but it's just like a native function from GPUs, most GPUs. So this is pretty much free on pretty much any more modern hardware. So let's save this as a variable of its own. So let's once again register a new variable. The shortcut for that is R-click. So you can register a variable quickly. And we're going to call this glitch lines. Let's put it like that. Okay, great. And now we're going to add this glitchiness to the UV, right? So if we use this UV, it is susceptible to changes either from the editor or from outside. So even our shader has already some manipulations on the UVs. So we actually want to take our vertex texture coordinate. So this is the raw UV that's actually on the 3D model vertices themselves. So this is pretty much as raw as it gets. And we're going to add to these UVs the glitchiness to them. But there's a problem though, because if I just add it right now, it's going to be too strong. These values are way too strong. It's going to throw off our UV completely. So what we're going to do is that we're going to multiply it by a strength factor. So let's create a new float. Let's make it a property. Let's call it glitch UV's strength. And once again, we can make it a slider. So let's make the maximum value like 0.2 and the minimum value can be 0 in case we don't want any UV distortion. Let's multiply that and then we add it. But the default value can be like 0.05 or something. Might be fine. Whoops, something happened there? What happened here? No, the default value is 0. Current value can be 0.05. All right, cool, fine. All right, we fixed it. Yeah, that's pretty much it. So now we have our glitched UVs that we can save once again in its own variable. So let's register this variable as glitched UVs. So now, if I go over here to my texture and I press G to get a local variable, I can get my glitched UVs and put them on the UV channel. And if I save this, you're going to realize that here on our hologram, I need to reset here. Now we have a glitched effect on the hologram itself. And we can play with these variables here. So for example, on the glitched UV strength, we can make it a lot weaker or a lot stronger. We can change the tiling of the glitch. Let's make it like 40, for example, so we have a lot more horizontal lines. And now we have the glitched effect on the UV side of things, and also the time scale. So if we want to make it really slow, we can put it like this, and now you can see that it's a lot slower, but it still looks interesting. Jesus fuck. So that is the first step of our hologram shader, which is the glitchy UVs. Now that our glitched UVs are done, we can go into the next step. Paramount look hologram effects are scan lines. And these scan lines in particular, they're really interesting because you can see here that this one is going vertically on the y-axis, but this one you can't see at all. Well, this is because it is going on the depth. You can see here now. This yields a really interesting effect because when you combine that with dithering, the model almost kind of dissipates for a very slow second and then comes back, and it dissipates into a bunch of, you know, tiny little blobs. And I personally really like that effect. So let's make the scan lines that we can use here on our hologram. So let's go. Much like before, we're going to use the noise generator for most of this stuff. So let's create our logic around here, and we can combine it later with our texture using named variables. So let's just create here a noise generator. And on this vertex generator, one interesting thing is that even though the UV is a vector 2, it actually can compute three-dimensional stuff, even being a 2D noise. So what we're going to take here is that for us to choose our actual as-is, we are going to manipulate, we're actually going to take our vertex position, and what we're going to do here is that we're going to create a static switch. So static switches, they essentially create multi-versions of your shaders based on a choice that you can pick from your material. So in our case here, the default options are false and true. That's not what we want though. So what we're going to do is that instead of being a toggle, we want it to be an enum, and we're going to have 3 options. So the vertex position has 3 as-is, and we're going to have 1 option for each as-is. So one for X, Y, and Z. So by default, it is going to go through the X as-is. I actually want it to be on the Y, so it's going vertically alongside the model. And we can plug these as the results. So this means that if our option, which is this one, is Y, it is going to use this input. If it's X, it's going to use this input, so on and so forth. So we're going to save this because we're going to be using this quite extensively. So this is going to be register new variable, and we're going to call this vector scanlines vector. So now what we can do is that if we take our scanlines scanlines vector. And if we just slap this into the UV, you're going to notice that now our noise already has the familiar look alongside the y-axis. If I change this to X, oh, it actually didn't change here on the preview, but trust me, it does change if you actually play through it. So what we're going to do here is that we actually want these scan lines to move over time, and we also want to control the scale. So let's make a new float because the scale is easy enough. Let's just make a property. Let's call this scanline 1 scale, and we can put this here on the scale, and it needs to be at least 1, right? Let's make it 3 maybe, who knows. And now we also want to add some speed here to this UV. So what we can do is that before we put it in there, we can add it to a time node. On the scale of this time, we can create a new float, which is going to be scanline 1 speed. Let's make it just 1 for now. Let's put here on the scale. So now, if I put this fella on our UV, you're going to notice that now we have, well, we want it to be going up. So let's make it -1 to invert it. So now you can see here that we have the scanline effect already in place, which is great. But we also want to do something else. These, once again, for glitchy text stuff, it's full of binaries. It's either on or off. So we could use step here, but the problem with step is that if we do step, it usually is very harsh values, right? With no transition between them. You can see here that it's black or white. What if I want to keep some of those values? Well, what you can do then is something called smooth step. So smooth step is the same principle as step, but you're going to keep some of the transitional values. So what we can do here is that we can make a new float, and let's call this, let's make it a property. Let's call this scanline stepping, and let's put it 0.2, something like that. And let's plug this into the minimum. And you can see now that everything that was 0.2 and below is now onto the blacks. We can make this a little bit bigger even if we want it. Let's use 0.25. I think that's a cool value to work with. So this is the bare minimum for us to get a scan line. Now, I personally want to have a second one, but this second one is going to be a lot more complex and have a lot more features. So we are going to use this. This is not work thrown away. We are going to use this, but we're also going to create a new and improved scan line that's going to add a lot more noise and a lot more grittiness and a lot more character to our hologram. So let's do it. So the first thing about this scan line is that I actually want to distort a little bit of it. So let's first make the distortion logic. So we're going to take our vertex position once again, and we're going to distort indiscriminately between the axes. So let's add this to time node. Oops, sorry, to a time node. And I want this to be really quickly in a Vertex. So let's make the scale here 3 so that it's really quick. Now we're going to plug this into a noise generator. And you can see here what this looks like. Right? Just a bunch of blobs. So what I can do to make this very granular, almost like a TV grain, is that I can make a new float, and we're going to call this a property, which is going to be scanline grains. Let's call it that. And let's make this a really high value, like 100. Let's put this into our scale. Now you can see here that this is really grainy. So now let's save this as our grainy noise here. All right, cool. So let's do the second distortion line here. So we're going to do a lot more UV manipulation on this one. So let's take our scanlines vector once again, and let's do some modifications to it. So let's add it to our speed here that we have. But what we can do here actually is that we can take this and we can multiply this, our scanline 1 speed. Let's move this a little bit over here. Hold on 1 second. Let me just reorganize my graph a little because I want these things to be close to each other, kind of like this. So what we're going to do here is that we're going to take our scanline speed and from our scanline vector, instead of adding it straight up, let's add a multiply, and let's say that this scanline, for example, is going to be half the speed. So we're going to multiply it by 0.5, which is going to essentially halve the speed of whatever value the scanline 1 speed is going to be. Now this is going to be our second scanline. So we're going to multiply this and we're going to create a new float value. And this float value is going to be called scanline to scale. And let's put this at a value of 10, for example, so a really, really high value. And interestingly, if I put a sign here, you're going to notice where we're going with this. This is awfully similar to this, right? But without using the noise. But we still want to add some complexity, and this is why we did this grainy noise here, because now we can add these fellas together, and when we put a sign here, you can see what's going on. We have this grainy looking thing here. Now, we're also going to absolute this, just so we get more normal numbers to work with. And now, with these numbers that are expanding through the whole spectrum and not just black and white, we can do a step anti-aliasing. And this is very similar to step, but it is anti-aliased, so you can see here the type of results that we can get, and we have a lot better of a fine-grained control into this. So what we can do here is that we can add a new float. Let's call this, it's going to be a property, we're going to call it scanline to stepping. Great. And let's see here what values could work well for this. Let's try something like 0.6, 0.7, something like that, just as a default value here. And you can see where this is going. Now, what we're going to do here is that we're going to essentially add this to our smooth stepped scanline. But before I do that, I'm going to multiply this. Nay, I'm actually going to divide this. And we're going to divide this by 4. So it's going to be a lesser intensity version of itself. And we're going to add these values here together. So now we have these two fellas here kind of working alongside them. So now that we have this, we're going to register this as a local variable, and we're going to call this scanlines. Great. So let's put this scanlines to, just so we know what we're doing. And here we have the final addition between them so that we don't obstruct our graph. All right, great. So now that we have our scanlines here, if you go over here and you get the scanlines and you multiply them. So if we multiply these little fellas here and we put this into the color, we put this into the emission, and we save it. Oh, we should also multiply this by the alpha. Sorry. So we also multiply this by the alpha and we save it. Ta-da! We have scanlines. Now these scanlines are just wildly strong, but you can play with these values, and by playing with these values is how, you know, you're gonna get the result that you're looking for. So even the scale here, I think it's a little bit you know, needs to be a little bit more there. Oh damn. Let's try something like 40. Well, that looks goofy. That looks interesting. All right, so on to the next we go. Actually, something else that we can do here, now that I think about it, is that we can actually do something a little bit more interesting here, and it's something that I did. Instead of us actually just using the scanlines like this, what we can do is that we can take our alpha and we can essentially lerp it. So what we can do here is that if we put our scanlines actually on the B and we keep the value A of the lerp as 1, we can actually have a property called scanline min strength. And we can set this to be, for example, minimum of 0.3, for example, and we can put this here on the alpha. And now if we multiply this by the alpha of our texture and we plug it in, well, let me replug the color and the emission first. And if we save it, we're never going to get into the blacks, which might be something desirable. This is not working, actually, but it's probably because maybe we need to invert this here. Let's see. Why is this not working? Maybe it could be one of the variables that are just acting up, so maybe I can just do this and click reset. What the fuck? Oh, okay, sorry. The actual mesh itself was turned off. Yeah, it was working, but yeah, you can see here now that we still have the scan lines, but now they're kind of like, you know, they're not going to the complete darks and the complete blacks. they're actually just hanging on there. All right, so now that we have the scan lines, let's go on to the next and final thing, which is going to be vertex offset. All right, so really quickly, just before we go to the vertex offset logic, let's just add the color multiplier. So you can just multiply this, press 5 and hold to create a new color parameter. We're going to make it a property, and here on attributes, check HDR. Let's make it just a tinge of blue here with a little bit of strength to it, and we're going to call this hologram color, and we're going to multiply here, because just so that we get a little bit closer to the final result, this final color multiplication actually gets us, you know, really close. So let's see here. Okay, I might have to play a little bit. Oh, this is set to alpha. We usually use additive. Oh, this is set to alpha. This is usually set to additive here. You can kind of see where this is going, to where it looks a lot more hologrammy when you have a little bit of a blue tint going on into the object. And now let's go for the final thing to our shader, which is going to be the vertex offset. Oops, no, not this. Let's go. So let's create a new block here for our vertex offset logic. So the first thing we're going to do here is that I just want to create some time controls, and these time controls are going to drive the UVs, and those UVs are going to be the things actually distorting the model. So let's just create a vertex position. After all, this is what we want to manipulate. So let's make vertex position, and we can drag and drop this into the scale and offset. This can be used through any number, not just UVs. And the scale, well, is going to be essentially, make a property here. It's going to be vertex offset scale. And let's make this 2, for example. Let's put it here into the scale. All right, great. I don't know why it didn't save, but yeah, we're just going to use a value of 2 there. And for the offset, we want to offset this based on a bunch of time parameters. So let's actually create a new property, and let's call this vertex offset speed, and let's make this 2 as well. Let's just make the, you know, let's just use this by default. Let's put a time node here. Of course, on the materials you can manipulate this to your heart's content, and we're gonna add this little thing here, and we're gonna add this to an offset number that we're gonna have as our baseline. Let's make here a new property, and let's call this vertex offset baseline, and let's put this at 0.5 for now. And once again, we can see what values work best on the material, so let's just add this up, and we might use this variable elsewhere in other places. And okay, so we should have this as our offset here, as our initial offset. Now what we're going to do as well is that we want to have a vertex offset speed for the X, and we want to have a vertex offset speed for the Y. So let's also put this on its own time node, right? One for each sides of the UV. Let's also add it to our vertex offset baseline, which we can manipulate later. Now let's append both of these things together. So let's append as a vector 2. So we can put this on the X, and we can put this, whoa. Hold on, buddy. You're going to be just the X. What are you talking about? There we go. So now that we have this append, we're going to feed this into a bunch of noise generators. So the first one, this is going to be our vertex offset speed. So the first one can be just it. So we can do here just a noise generator. So we're going to have this generator here, and you can see what it looks like. It's just like doing a bunch of lines. But the interesting thing is we want to have a little bit of a more granular approach to this as well. So here we have our UV, but we want to have a more granular version of this. So to do this, what we can do is that we can drag our append and we can split it. And on this split, what we can do is that we can keep our Y the same. So let's append it here and put this on the Y, so we keep that value, and on our X we can multiply it by a multiplier. So in this case we can put here just a ludicrous number. Let's put it 20, and if I put this on the X and I plug this into the UV, you can see now that we have much smaller, finer grains of lines there. and these are going to be kind of our micro distortions. So these are really macro distortions, and these are micro distortions, if you will. Now, finally, the last thing we want to do is that we want to be able to control the intensity of these glitches there. So what we can do here is that we're going to add both of these things together. Right, so here we have like all of these little noises here, and actually what we can do even is that we can multiply them before we add them by 0.5. So you can just multiply them by 0.5 and put this here. We can multiply this by 0.5 and put it there, so that we don't go into like the super high values, you know. And we're going to remap this, and essentially what we want here is that we want to go, essentially want to set our minimums and maximums should be between 1 and -1, because we want to do these things on all of the as's and also on their negative values. So we're going to do here, our min old is going to be -2 and 2, and finally, actually I think it clamps out at 1, and then our min new is going to be from -1 to 1. So now we have this remapped values here. And finally, before we finish it up, remember that we saved this glitch noise here? Well, let's get it again. So let's get our glitch noise. So let's do G to get. Let's get glitch noise, and let's multiply these things here. There we have it. So now the glitch also has a little bit of randomness to it. And finally, we also want to multiply it by a constant, not a constant, but a property that we're going to call glitch offset, vertex offset strength. Let's make it also a slider from 0 to 1, and let's make the default value really, really tiny, like 0.05, you know, something like that. Let's do the multiplication there, because usually whenever you do these things, it gets really silly really quickly. And also you can choose to turn it off, you know, by setting it to 0. Now, I believe if we just plug this into the vertex offset, we are going to have a glitched hologram. Hell yeah. You can see here that now we have a little bit of a vertex distortion going on. Of course, if we want to have a more visible vertex distortion, if we just increase the strength, you can see here that we start getting really, really, really silly distortions going on. We probably want to keep it somewhat contained. But yeah, this is how you make a hologram shader very feature complete, and you can play around with the values and you're going to get some, you know, crazy good looking results like these ones. So yeah, I'm pretty happy with the result. Hopefully you guys enjoy this, and hopefully my stuttering has not annoyed anybody. So yeah, thank you for watching. Thank you so much for watching. Do not forget to like and subscribe if you liked the video. This shader is really, really great. Leave in the comments any suggestions for future tutorials, and check out our Discord server where we always have updates on our Unity Asset Store stuff, also tutorials, any and everything. If you have any questions, reach out through there as well. We're always answering questions. Thank you for watching, and goodbye.